So we're going to use calculator technique here to work out the regression equation of the line of best fit through some data. Now we referred back to the weight loss clinic data which we've done previously using a two-point technique, fitting the line by eye. Now more sophisticatedly we can do it on our calculator. Now I'm using the Casio ClassPad 400. This video will also help you if you've got a Casio ClassPad 300, but if you've got any other brand of calculator, you'd be best just to turn the video off and go to your calculator companion and have a look through the notes in there. Now, on the Casio, you'll go into the statistics menu. If you've already got some data in there, you can clear your data by going Edit, Clear All. Are you sure? Yes, okay. It's gone. Now, I want to enter the data for the weight loss data there. So you'll notice too that the way the Casio has this organised is always in columns. Yet our original data here was presented to us in rows. Now we're going to have to sort of transpose it across. So we want our first column, our list 1, to be the months. So let's enter the data for months first. So press XE after each piece of data, so it's 0, XE, 1, XE, 2, XE. Enter all your data down to 6 months, and then click across, toggle across and click in list 2 and enter your Y data. Now each piece of Y data has to be next to the correct corresponding X data. Okay, make sure you've got all your data there. Make sure it's all entered correctly, and then we're ready. Before you draw one of these graphs, it's often a good idea to set up your graph correctly. So look under Set Graph, and we've got Graph 1 we're looking at, and click on Setting for Graph 1. It tells us the type of graph we're going to draw is a scatter graph. That's good, we want that. Of the X list is in list 1, the Y list is in list 2, that's really good. Frequency is 1, that just means each piece of data was entered individually. And they're all going to be marked with little squares. All that's okay. I can click Set, so that's all ready to go. To draw the graph, look up to the top left-hand piece of the corner of the screen, and you'll see a little graph there. If you click on that, it will draw the graph for you. Okay, now we're ready to do our linear regression, to calculate the equation through those scatter of points. Now, very importantly, to draw it, you must have, you see you've got two parts of the screen here. The top is our data, the bottom is the graph. You must make sure the graph is selected. We'll have a dark line around it, mine's outlined in blue. If you've got the top selected, you'll have some different menu items available. So only with the graph itself selected, you'll see that one of the options at the top of the screen is Calculate. We want to calculate a regression. Click on Regression, and the type of regression we want is a linear or straight line through them. So click on Linear, and it said, is it a list? X list is list 1, the Y list is list 2. All of that is okay, so press OK, and it will come up and see how it presents its answer. Probably not as neat as it could be, but it tells you that the graph is at the top there, y equals ax plus b. That means it's a straight line relationship, and it tells you the values of a and b. Now the calculator has said, using a sophisticated regression technique, the relationship is y equals negative 0.760. I'll write this down. For the weight loss data, y equals negative 7.61, it will be, x plus 127.25. If you want to put that in terms of weight and months, you could say on the y-axis we have weight equals negative 7.61 times the number of months plus 127.25. Okay, so that's the relationship it's given us. Notice that that is marginally different from that which we calculated. I'll just bring back our calculations that we did for the weight loss data. Just fold them up a bit more on the screen. And this is what we got before. We got weight equals negative 8.4 times the number of months plus 130. Now, we've got very similar results, not exactly the same. I would tend to say that this regression technique is a little bit more accurate than what we did when we were trying to fit the line of best fit by eye.